In this video, we are going to continue our discussion on exponential functions. This time, we are going to specifically look at application problems. So we'll see how these exponential functions could be seen in the real world. So every time that we're working with some kind of exponential growth or decay that has a constant percent increase or decrease, we can use the following formula. I'm going to give you the entire formula first, and then we'll go through and talk about what each of those pieces represent. So we'll always start with y equals. I'll have an a out front. In parentheses, I will have 1 plus or minus r with an exponent of t. Okay, this a value that you have, this is your starting value. So maybe we're looking at the number of people that get coronavirus. If it started off with one person, this a value would be a 1. If it started off with 2 people, then this a value would be a 2. We'll always have 1. If it's something that's growing, so like the number of people with coronavirus is growing, so that would be a plus. If it's something that's decreasing, then we would subtract. The r value is the rate in which that thing is increasing or decreasing. This rate will always be given to you as a percentage. Okay, again, you're going to do your 1 plus r if it's growing, 1 minus r if it is decaying or getting smaller. This t value is always your time. All right, let's go ahead and look at an example. So this first one says, according to the 2000 census, the population of Dayton was 1,420 people. Since then, the population has grown by approximately 2.03% annually. The first thing that we want to do is figure out whether this is growth or decay. Well, because it's saying that the population has grown, that means it is increasing, it's growing. Okay, next we'll have to identify what we think the x-axis and the y-axis represent. I like to go back through and reread my problem and figure out the two things that they're talking about. There's always going to be kind of two different things. So in this case, they're saying the 2000 census, they're talking about the population of Dayton, so that's probably in people. It says since then the population has grown by approximately 2.03%. So one of these axes is going to talk about the number of people, and one of them is going to be the number of years. So because they're giving me the starting value of 1420, I'm going to guess that this y-axis is number of people. And that means that my x-axis is the number of years. And I'm going to be really specific here. It's the number of years since the starting year, which the starting year was 2000. So I'm going to say number of years since or after 2000. All right, next up, I need to write an equation that represents the data. When I go to write that equation, I'm going to use the formula that we talked about up here. So I'm going to put y equals, first thing I need is my starting value. That is also your y-intercept. So it says that we started out in 2000 with the 1,420 people. I'm going to open my parentheses. I have 1. Because I'm growing, I'll put a plus sign. And then I'm going to put this growth rate. What's kind of tricky about this is that they'll typically give you the growth rate in a percent, and we need to change that out of a percentage. So we're going to take the decimal, we're going to move it 2 to the left, so 1, 2, which means there would be a 0 right here. So my rate is really 0.0203. I'll close my parentheses, and the time will just be my exponent, just going to put a t there. I'm going to do a little bit of simplifying here and combine like terms inside those parentheses. So my 1420 would stay the same, but 1 plus 0.0203 would be 1.0203 with an exponent still of my time. In part E, it says to use the graph to determine the range of values of Dayton's population in 2021. So the first thing I need to do is find where 2021 is on the x-axis. Well, if my starting value was the year 2000, that means that I'm going to go over to 21, so right here. And I'm going to draw just a straight line up from 21. So it looks like somewhere right in here. Now, can I see exactly what the population was in 2021? No, because it's not perfectly on there. So that's why we're going to give a range of values. So I know that it's somewhere in between these two. I'm going to draw these guys just kind of horizontally across there. If this is 2000 and this is 2200, that means this is 2100. So I don't know exactly what the population was, but I do know that it is between 2,100 people and 2,200 people. If it asks for range, you always write your answer like this. It's somewhere between these two values. And the last part here in part F, they want me to use the equation to make a prediction. So I'm using the equation that I had in part D. So I'm going to take this equation here, and it's looking for the population in 2025, which would be 25 years after my starting value. It would be like right over here on my graph, but it's too far over. And I'm just going to take that 25 and plug it into t in the equation. So I'll have my 1420, the 1.0203, and now instead of t, I'm going to put 25. From there, I'm just going to plug that guy right into my calculator. So I have 1420, parentheses, 1.0203, and the exponents 25. So that gives me 2,346.85. Now, because this is talking about people, I can't have 0.85 of a person. That just doesn't make sense. So for my final answer, I'm going to round this up to 2,347 people. Go ahead and pause your video. I want you to try the next problem here. Here are my answers for the next example. One kind of hint if you're getting stuck between the x and the y-axis is your x-axis is always going to talk about time. This x-axis here, like 90% of the time, talks about time, so you can kind of use that to help guide you. Again, using the formula that we saw up in the top, so I should end up with my starting value of 79.7 and then 1.035 with an exponent of t. When I'm looking for the range in 2010, we went on the x-axis to 10, that would be 2010. We went straight up and this dot was there, and so it looks like it's in between 110 and $115 billion. Make sure you're specifying here that we're looking at billions of dollars, not just $110. And the last one, I'm plugging in 18 to represent my 2018 here, and I got $148.04 billion. The next example here is going to be very similar, but this time it'll be a little different because we're going to look at decay. So it says, a cup of green tea contains 35 milligrams of caffeine. The average teen can eliminate approximately 12.5% of the caffeine from their system per hour. So because we're talking about caffeine that's leaving the system, or you could look at this word eliminate, this is going to be a decay function. So we're talking about caffeine that's leaving the system, and it's saying that it's leaving per hour. Again, my x-axis is typically time, so x-axis needs to be number of hours. And then the y-axis is representing the amount of caffeine that's left over. And it looks like that caffeine's measured in milligrams. So I'm going to label my y-axis as number of milligrams. So at 0 hours, there are 35. After 10 hours, it looks like there's going to be roughly 10 milligrams left. Just like we saw in that last one, I'm going to start with writing the equation. So I have y equals, I need to start with my starting amount, which they said it originally contains the 35 milligrams. I still have 1 inside the parentheses, but now because it's decaying or going down, we're going to have a minus sign. Again, I'm going to put my percent here after I move the decimal 2 to the left. So 0.125, close parentheses, and I have my t as my exponent. Again, I'm just going to rewrite this here, but I'm going to combine those like terms in the parentheses. I need my calculator for this one, so I'm going to type in 1 minus you can't see, 125, and I get 0.875. Again, I need to find a range of values of the caffeine in the system after 8 hours. So I'll go over to 8. It looks like it's somewhere in here between 10 and 15 milligrams. And then the last one, I need to use the equation to predict the level of caffeine after 16 hours. So I'm going to be using this equation up here. I have 35.875 with my exponent of 16. We'll plug that guy into our calculator. So 35.875, and my exponent was 16. I got 4.13, and this is again in milligrams. I don't need to worry about rounding on that one because I can have 0.13 of a milligram. I only rounded on the last one because it was talking about number of people. Go ahead, pause your video. You try example 2. Here are the answers to example 2. If you got any of them wrong, please take a minute to check over and try and find your mistake. All right, example 3 says, given the graph below, answer all of the following questions. So first thing I need to do is classify whether it's growth or decay. Looks like things are moving upwards, so I'm going to assume that this is growth. And from here, I'm going to create kind of my own scenario. I personally like to do B and C at the very end, and I'm going to write that scenario first, and then I'll go back and think about what my X and Y axis represent. The first thing I'm going to do is start off with finding my starting point. So looking at my graph, it looks like it's starting here at 0, 20. And then I'm going to find one other nice point. So usually you'll be able to find a few nice points. It doesn't matter which one you choose, just pick one nice point. So it looks like I have a point here at 2, 22. You could also pick, let's see, where's another nice one. It looks like here's a good one at 6 and at 25, 26, 27. So I could do one at 6, 27 as well, as long as you're picking one other nice point. Okay, this is kind of the hard part where you get to come up with your own scenario. I like to kind of think about the x-axis first, so it has to be something within 0 and 2. So maybe I'm looking at hours. And then I want to try to think of something in the real world that could grow exponentially. So maybe I'm looking at somebody who's trying to become Instagram famous, and this y-axis could represent the number of followers that they have. As the hours increase, their followers increase. They're becoming famous. So I'm going to start there and write, well, I guess I can start with listing my x and y axis. We said the x-axis is number of hours, And my y-axis is number of followers. So first thing I do when I'm writing this scenario, I'm just going to kind of put in context what I'm talking about. So we're going to say Mr. Muth is trying to become Instagram famous. Next thing I'll do is list what this starting point was. So when Mr. Muth started out, he had 20 followers. So when he started, Muth had 20 followers. The next thing I'm going to do is talk about one of these other nice points. So I'm going to use this point of 220. The 2 is representing hours, so I'm going to say after 2 hours, and then I'm going to talk about this 22. This is his numbers of followers, and I also like to put in there that we think it's growing exponentially. So I'm going to say after 2 hours, Muth believes he will have 22 followers, and it will continue to grow exponentially. So there's lots of different scenarios you can choose here. Some common ones, you could look at the value of something. So maybe you started off buying some kind of sports memorabilia that was worth $20, and as every year goes by, it is going to increase in value. So after 6 years, it would be worth $27 now instead of $20. You could talk about opening some kind of bank account. So maybe you open a bank account and you put $20 in there. And every year that passes, you are going to earn money on that bank account. You're going to earn interest. So your value would be increasing. There's tons and tons of different things that you could write for these real world problems. Go ahead and pause your video. We want you guys to try example 3. All right, for example 3, everyone probably has a different scenario written down. Everyone should have circled decay because it's moving downwards. I wrote out just 3 of the nice points that I found. There's lots of different things that you could have chosen for decay. You could have said that Mrs. Soto starts with 160 pieces of candy, and every hour she's going to eat more and more candy, so eventually those pieces will go down. So after 8 hours, she'll only have 45 pieces left. After 3 hours, she'll have 100. You could say that your bank account starts with $160, but every week you are taking money out. You're not putting any money in, you're just taking money out. So after 3 weeks, you only have $100. After 8 weeks, you have $45. Anything that is decreasing and moving downwards that makes sense in the real world would work for this question.